Hello, my dear students. Welcome back to the lecture. So in this lecture, like I mentioned, we are going to find the distribution still now. Okay. So how we are going to find the distribution still? So for that, what I'll be doing, we'll shift in between two windows now. One is this window, and then I'll open one Excel sheet. Okay. Then we'll switch in between two windows. Yeah, this should be fine. Okay, fine. So this is a Excel what we had created for the slab, isn't it? So you have to look into the top reinforcement. Bottom there is no distribution still. It is main bar and distribution that we already taken care of. Now we are concerned with this part, isn't it? So for that, this is a drawing what I have. Yeah, yeah. So I think where shall we start it from? Okay, this was bottom shorter and longer we had done good. ABC placing in ABC, fine. Now we'll come to this part. Okay, fine. Top extra we started, isn't it? Now you see, if you remember top extra at junction A. Okay, this is junction A for me. At junction A, you can see here top extra bar at junction A, grid 1 to 3. That means if you remember, I had explained you how to find the cutting length of this bar, isn't it? So this cutting length I had explained. Your bar will be like this. This bar I had explained you, isn't it? So now again I told you, whenever you put a bar in this way, so at 1, 2, 3, no? Yeah. Whenever you put a bar in this is top still. You're able to understand, no? We have to put the distribution still. But I told distribution still, I'll explain it later. I didn't want to make you confused. Now I want to find this distribution still. Okay. This distribution still, length and number I need to find. This much you can understand. If you still find it difficult, let me show you one practical image for that. See. This right now we found out this part, no? This was the bar which went like this. This was the bar which went like this. But you can see the distribution still here. So this other distribution still coming beneath that. This will be like this. Under this, your distribution still will come. Okay. So we want to find the cutting length and number of bar of this distribution still. That we didn't find. But now I'm going to teach you that. Okay. This much is understood. Yeah, we'll go back now. So I want the PDF now. Yeah. So how we are going to do it? It's very simple. This straight length we knew. This length I want now. Only this straight length I want. So that you can see here, this is 1650. You're able to understand now. This was 1650. So that is 1650. Okay. Now I'll find the distribution length first. That is, whenever you put the distribution bar, no, your distribution bar will be from here. Okay. From here to here. Only this much part for this slab. And then from here to here, this length I need to find. What I'll do, since we took 1, 2 and 3 grids simultaneously, I'll calculate length from here to here completely. And then from here to here, I'll completely. Then I'll deduct the middle of the beam, because in the middle part, your distribution still won't come. If you're asking me, sir, why you didn't take, for example, yeah, I'll show you one image here. Hmm. So see, practically these people give. These people, in order to cut the bar, what they do, they give it. But actually your top extra bar is starting from the beam face, right? From the face of the beam. And also from here, it will start from the face of the beam. That means your distribution bar also will also end up to here. Your distribution bar will start from here. And for this span, it will start from here. But practically on the site, what we don't do like that. We take one complete bar and we pass that. Because if you want to cut again, it's a simply you're wasting the bar. No, you cut the bar and then we don't do. But when I find the cutting length, we'll find exactly how much bar will go. This is a contractor problem. In order to avoid the problem on the site, he is just putting the complete bar. But actually your bar will only end here and then it has to start from here. But he doesn't want to make all this cut and all. That is why they'll bring the straight bar. But we'll do the half only we are going to do. That means what I'm trying to tell is, whenever I find the length, this whatever is the beam width, so that we need to deduct, no? Because inside the beam also your bar is passing. We don't want that. Okay. That is why what we do. That is why when I calculate the length, so this length I know. From here to here, how you'll find the length? Very simple. What you do? This length is given from center to center. That is 7,500 minus 150 from here. Your beam is 300. Half of the beam from here. Half of the beam from here. So you got the clear span. That means clear length you got. But again, I mentioned this is a beam what we have here. So practically this is that beam. So this beam, you're not putting the bar. Your bar will actually end here. It will start from here. It will end from here. That's it. Okay. And then again, it will start from here. It will end from here. Just because a contractor who doesn't want to cut the bar, they will put practically straight bar. But we'll do the cutting length what is exactly required. Got it, no? So what we'll do, in 7,500 minus 150 from here, minus 150 from here, and this middle 300 width of your beam strength, that also will deduct. This much you understood, no? Good. So now I'll go back to this now. Yeah. Fine. So that's it. What I have written? What I have written? Distribution bar. This length I have found here. Okay. See this. What you need to do wherever you have done this top left extra, top right extra. See, I'll tell you how it has to be done. This was the earlier drawing what I had where I didn't do the distribution still. So what you do, you keep your mouse here and click on the control and plus button. So in that way, you'll be adding lot of rows. Okay. Once you add all the rows, you just come here, take one bar. This you can copy the same thing, Control C, and just paste a bar here. That is Control V. Keep it here, and then you should write here distribution still. Okay. Distribution still. Okay. Write the same thing whatever you are written. Distribution still at junction. At junction. What is that? Whatever you have written here. Beneath that only you are finding at junction A, and on the grid 1, 2, and 3. So it's understood that this distribution still you are providing here in this direction. Got it? Fine. This length how we'll find? So you'll come here, say plus. What is the center to center span? 7,500, no? So 7,500 minus half the beam from here. So 150 minus half the beam from here minus, what is this? Beam, no? 300 mm. I'll do minus. Finish. So this is a cutting length what I have. 6,900 is the actual cutting length what I require. You're getting my point. Else, if you don't want to do in this way, you can take it separately. Then also you'll get the same answer. If you want, I'll do that. See, I'll take this length from here to here. I'll take this length from here to here. Then also if I add both, I'll get the same answer. Let me do. This is 3750, no? So I'll write 3750 minus 150 on this side beam. This is 150 beam. And this is also 150 beam. Okay. So minus 150. How much you'll get? So 3750 minus 150 minus 150. So it is 3450 mm. Okay. So this is also 3450. This also remains same 3750. Here also 3450 will come. I'll write 3450. 3450. Finish. Now add both the thing. You should match the answer. 3450 plus 3450. So if I do that, that's it. 6,900 I'm getting manually. And you can see the same thing has come in the Excel sheet. Okay. But you should be clever enough to do everything in a single sheet. Okay. You don't have to do this separately, this separately. Okay. Got it? No? Fine. Fine. After that, what you do? After that, it's very simple. Number of member, obviously it is 1. Diameter of the bar. See, here in this drawing, everywhere your 10 diameter bar is given. Yeah, I'll show you one more thing. Whatever I'm trying to tell you, no, it is mentioned here. See, if I come to the cross section, I'm finding this part. No, yeah. See here. This is your top. Okay. This was your top steel, which you had provided. That is top left. And now you can see the dotted portion here. This is your distribution steel I'm trying to find. This dot portion I'm trying to find. 1 dot, 2 dot, 3 dot, 4. This dot I'm trying to find. Okay. Getting my point? No. Now you see here what is mentioned. They have mentioned that you need to provide a 10 diameter bar at 150 center to center. That is your top extra. And the distribution steel what you're providing, that also is mentioning here. This is showing in this way and telling it is also 10 at 150. So most of the drawing, usually it will be double of this. Here, luckily we got it 150, but in some of the drawing, usually the distribution steel, no, we increase the spacing. Okay. If this is 150, your main steel is 150, distribution will be 300 to 300. But here they are given 150, 150, it's okay. And also remember, this distribution steel, you won't get in all the drawing. Whenever you start to work, people will not give you the distribution steel spacing. So usual technique, what we follow is whatever is your main bar spacing, no, that is 150. You have to double that. 150, what is double of 150? 300. So your spacing will be 300, 300, 300. But here we have got it, so we'll take that. Okay, fine. This much is understood, no? Great. Now nothing. It's very simple after this. Okay, fine. It's very simple. Yeah. Now we'll find the number of bar. Where we are now? Yeah. So this is the portion, no? Yeah. So how you'll find the spacing is not given. Number of bar is how much? Yeah, number of bar, I don't know. How you'll find the number of bar? If you observe this drawing carefully, wherever your top extra bar is starting, only there you are going to put distribution. This bar was starting from here. This bar was starting from here. This bar was starting from here. That means your distribution also will go only up to this distance. Okay, like this is your cutting length we found. It will be only going till the length of this. Last up to here it will go. That's it. Finish. That's it. Got it? So whatever is your this length, that I need to take that distance I need to take to find the number of bar. You're getting my point? If I want to find the number of, this is the cutting length I got. This is the number of bar if I want to find. I'm going in this direction. So my span will be this one. So from where I get this span? This span is nothing but this span is nothing but this span. Right? Agree with me? This span is nothing but this particular span. 1650. So here only your distribution still will go, no? I'll draw it here in this way. Now you can get an idea. Your distribution still will only go in this point beneath this. 1, 2, 3, 4. And hardly you'll get 5, 6, or 8. Around 8 to 10 bars you'll get. Not more than that. Getting my point? Fine. So practically also if I will show you this. See how many bars are there. Just try to count. This is 1. 1. Then you have 2. Then you have 3. You have 4, 5, and 6. That's it. 6 bar. And how did I count this 6 bar? Whatever is this length, I counted from this beam outer, that is inner of this beam, to this length I need to find. And whatever length I get, that I need to divide by the spacing of this distribution, which is already 150. If I do that, I'll get the number of steel. Understood, no? Very simple. That's it. So if you understand this concept, it's very simple after this. I'll do the same thing now. So in the number of bar, what I'll do is, I'll click on this. I'll open the bracket. I'll say 1650 divide by spacing. So spacing, I need to click on this. But wait, I'll do spacing is 150. Now I'll write 150. And now I'll write plus, open the bracket. Say 1650 is a clear span. Okay. Divided. And yeah. So this answer I need to divide by spacing. I'll close the bracket. Then plus 1. You're finding the number of bar. So you need to do plus 1. So plus 1. Finish. You'll get 12 number of bar. Got it? But you have to do round up. I always tell you whenever you're doing, what is that? Yeah. Whenever you're doing number of bar, you should always say plus 1 dash comma 0. Close the bracket. Hit the enter. 12 number you'll get. Okay. Got it, no? After that cutting length, you can find cutting length. It's simple. This itself is your cutting length. And this if I divide by 1000. Finish. And then total cutting length will be 6.9 multiply by number of bar is 12 multiply by number of member. Finish. This is total cutting length of all the distribution steel. And weight, since it's a 10 diameter bar, you have to put it in the 10 diameter column. 82.8 multiply by 0.617. Finish. 51.08. The same answer I have got here. I think I should get. See, already done and kept it. See, 51.08. Got it, no? If you understand this, after this, whatever calculation is the same thing. Wherever the top left, top right has come, this length only I need to take. Divide this by spacing, you'll get the number of bar of the distribution steel. Simple. Got it, no? That's it. Finish. I think with this understanding, I'll go forward one by one. Okay, for one I did. Next, we'll go again. Next, what was written here? Top extra bar at C junction on grid 1, 2, 3. What is written? Top extra bar at C junction on grid 1, 2, 3. So I think I should use in this way. Yeah. So top extra bar at C junction. So where is your C junction? So this was your A junction. A junction. So this is my C junction now. So this is my C junction. Okay. This is my C junction. C junction, this complete thing. One thing you understand now. One thing you need to understand. Here you have to apply your logic. Whatever cutting length I found here, the same cutting length will be here. So your one problem is solved. Cutting length problem is solved. Whatever you got here, same thing you have to copy here. Another thing, you have to find the number of bar. To finding the number of bar, you just check what is the length you got here. From here to here, what is that length? So that is length. How we are going to find? You have to look into the cross section C. So if I go to, you don't have to look there, just come here, directly the value is given. See, top extra bar at C junction on grid 1 to 3, this is 1550. Finish. So 1550 divided by number of bar plus 1 will give me the number of bar in the number of distribution steel. This much you understood. Same thing I've written. See, again the cutting length remains same. Whatever I did here, same thing I control C and control paste, you do it. Okay, I think you should know all these things, but still I'll do. Now, what I'll do, again, I'll control copy this. Okay, I'll say control C. Now it's not possible. So after this, I need to do, see, after this, I need to do, come here. increase this thing. Okay. Then you copy from here, copy this part, say Control C, come here and paste it here. Okay. Control V. Got it, no? And then you do the calculation, whatever you are supposed to do. Already I've done and kept it. So the same thing will happen. Cutting length is 6,900. Only the number of bar will change. So number of bar, how I will find? Very simple. Round up 1,550. This is what I have selected. Divide by 150 plus 1 I am supposed to do. Then comma 0, close the bracket. You will get the number of bar, which is 12. And total cutting length is 6,900. And if you put in meter, 6.9. So answer again remains the same. So this observation you should have, because whatever bar I had, same bar I'll get here. Okay. There is only 100 mm difference in the span. Like this is 1550. This was 1550 now. Earlier case, it was 1650. 100 mm difference is there. But since we are rounding up, actually, if you don't round up this, no, where is that? Yeah. If I don't round up this portion, I'll get answer in decimal. I'll get some 11 point something. Okay. I'll get, okay. Now it won't happen. Leave it. Not required. Okay. You do that. You'll get the same thing. Okay. Fine. Understood, no? So where we did 2 points we did. This is done. This is done. Next, center. Come to the center. Center is a bit interesting. In the center, what happened? If you remember, this is how we had put the bar. Center. This is how we had put the bar. Now your distribution still you need to put 1, 2, 3, 1. I'm just putting 3 numbers just to make you understand. It's not 3 exactly. Okay, fine. How will you find this? Very simple. Very simple. Cutting length again remains the same. Do you agree with me? Whatever cutting length you got here from here to here and here to here, here also cutting length will remain the same. So your cutting length problem is solved. Only the number of bar you are supposed to find. So what you'll do, you know this magenta color. You know this magenta color, right? Whatever is that magenta color, that is already given here. If I show here, see, this is magenta color. Where is that? Yeah. 3,500 is that magenta color. Okay. That is 1,650 from this side, 1,550 from this side, and middle is 300. But if you observe one thing, this distribution still will be gone only in which area? Your distribution still will be only in which area? Only from the face of the beam, face of the beam, face of the beam, and face of the beam. No distribution still will come over the beam. That means whatever is the width of my beam, that I need to deduct. Only then I'll get number of bar. Very simple. So just that's it. Finish. Come here. So what you did, I just come here. This is where is that? Yeah. See, I've written. Okay. See, sometimes you get confused. Okay, fine. See, top extra bar at B junction, grid 1, 2, 3. So this is my B junction. B junction. So grid 1, 2, and 3. This much is understood. Come. Fine. After that. So this was 6,900. That is common everywhere. Come to the number of bar. So number of bar, what I have done? This is 3,500 I have taken. But this includes even the beam thickness. So what I did, 3,500 minus the beam thickness was 300. That I deducted from that. In that way, what I got? From the face of this side, I got the length. From the face from here, I got the length. Now this I'll divide by spacing, which is 150. Now I need to do +1 or +2. I need to do +2. Why? Because for a very same reason. Because you're putting the bar in this way, no? See, if I had done only this span, if I had explained you only for this span, what you would have done? You would have done +1 on this side. But since we are doing it for both the span, so +1 for this side, +1 for this side, because it is a spacing. That is why I've done +2 here. Got it? This much I've understood. I mean, this much I've taught you. So number of bar will come 24. Cutting length is 6,900. In meter it is 6.9. Total cutting length will be 6.9 into 24 into 1. That's it. And the weight of the 10 diameter bar, how much it will be? 165.6 multiplied by 0.617. This will give me the total weight. Finish. So in this way, what we have done? Horizontal part we have done. Okay. In this way, I found the distribution still from here. I found the distribution still from here to here. I found the distribution still from here to here. I found the distribution still from here to here. If you remember, in this way also you're supposed to go, no? Here also your distribution still will come. Here also your distribution still will come. Here also your distribution still will come. That also I need to find. That's it. So in the next lecture, I'll take that. Okay. So in the next lecture, I'll take you how it has to be done. Same thing. You can see practically from here. If you ask me, sir, what you are trying to tell, what I'm trying to tell is, see, this distribution steel we are done. Right now, this was a distribution steel. I mean, this was a top left extra, I would say. And for this, accordingly, I taught you how to prepare the cutting. This one, straight bar, we did. This side also we did. Now, who will do on this side? Here also you have, no? This distribution steel also you are supposed to find, no? That we need to find. Okay, got it, no? Just I'll scroll down some images, I mean, this thing, so that you get an idea. See, practically once we do, no? This is how your beam looks finally. See, this is how that cutting length, you see. Straight portion you wanted, no? This is that straight portion. So on this side, you have certain numbers. One distribution beneath this, second distribution, third distribution. Similarly, one distribution, second distribution, and third distribution. Got it? That's how it is. That is how it has to be done. Fine. You can see it here also. Here also you can see it practically. Practically, I'll go back again. Yeah, this is thought. Yeah, you can see here. See, this is how it is. This guy is cutting that. Now, if you tell, see, barbender has brought all the rebar and kept. Now, when you're working on the site, actually, this will not work out on the site all the time. On the site, you have to take the site measurement only. This is only for our estimation. Inside, what will happen? You have to come and take this dimension. Now, you have to measure this from here to here, how much it is. And based on that, we'll do. But again, answer remains the same. But on site, we need to come and do the dimension. That's it. On site, you come, take a tape and do the measurement, like where this guy has cut the bar, this top extra from here to here. You measure it. If it is like, let us say 2 meter, so 2 meter divided by spacing of 150, you get the number of bar, and accordingly you tell him how much should be the cutting length of the bar. That is why these people have brought the rebar. They have the cutting machine here. Based on that, they're cutting it, and you can see this guy is just putting it here, and then with the help of binding wire, they do the work. Okay, fine. So finally, it looks like this. Yeah, this is how it looks. See now, here all the bar you can see, no, this junction, this junction, this junction, no. Here also distribution steel you can see. This part also distribution steel you can see. This part also distribution steel you can see. Here also you can see the distribution steel. Okay, and this is what this was for the bottom I explained. That's it. So we'll see you back in the next lecture. Thank you. Try to practice it. I think you have got an idea. What you do before you watch my next lecture, try to do it for the other side. So it will, in that way, if you go wrong, you'll get an idea. I think I did up to here, where it was. Yeah, I did up to here. You go for this one, you do it. Go for this one, do it. And the straight two bar will come in the middle. That also you do it. Okay, great. So we'll see you back in the next lecture. Thank you.